Hidden deep beneath the Pacific Ocean lies one of the most mysterious and controversial places on Earth. A region so dark and remote that sunlight has never reached it, yet so valuable that it could shape the future of global energy and technology. This place is known as the Clarion Clipperton Zone, often called the CCZ, a massive stretch of seabed located between Hawaii and Mexico at depths ranging from 4,000 to 6,000 meters below the ocean surface. To understand its scale, the Clarion Clipperton Zone covers approximately 4.5 million square kilometers, making it larger than India and nearly as large as the entire United States. On the surface, the ocean above it looks calm and empty, but far below, under crushing pressure and freezing temperatures, lies a hidden world that has remained untouched for millions of years. What makes the Clarion Clipperton Zone so important is the presence of polymetallic nodules, small rock-like formations scattered across the ocean floor like stones on a desert plain. These nodules may look ordinary, but they contain some of the most valuable metals needed for modern life, including nickel, cobalt, copper, and manganese. These materials are essential for electric vehicle batteries, renewable energy systems, power grids, and the devices we use every day, such as smartphones and laptops. What makes these nodules truly extraordinary is how slowly they form, growing only a few millimeters over millions of years as metals slowly accumulate around tiny particles on the seabed. This means that once these nodules are removed, they will not regenerate within any meaningful human timescale, making them a non-renewable resource on a geological level. For many years, scientists believed that the deep ocean was mostly empty and lifeless, but recent research has completely changed this understanding. The Clarion Clipperton Zone is now known to host thousands of species, many of which exist nowhere else on Earth. Some organisms attach themselves directly to the nodules, using them as hard surfaces in an otherwise soft and muddy environment, while others live in the sediment around them. When the nodules are removed, entire ecosystems are destroyed along with them. Even more concerning is the fact that many species in this region have not yet been identified or named, meaning that deep-sea mining could wipe out life forms before science even knows they exist. This hidden biodiversity may play a role in regulating ocean chemistry, storing carbon, or offering insights into evolution and future medical discoveries. To collect these nodules, companies plan to use massive deep-sea mining machines that resemble underwater tanks or industrial robots. These machines crawl across the seabed, vacuuming up nodules and crushing everything in their path. The collected material is then pumped to the surface through long pipes, where it is processed on ships. However, the damage does not stop at the seafloor. Mining activities create large sediment plumes, clouds of disturbed particles that can spread across hundreds of kilometers, smothering marine life, blocking oxygen, and disrupting food chains far beyond the mining site. Scientists warn that the long-term impacts of these sediment plumes are still poorly understood and could cause irreversible harm to deep-sea ecosystems that take thousands of years to recover, if they recover at all. The Clarion Clipperton Zone lies in international waters, meaning no single country owns it. Instead, it is managed by the International Seabed Authority, an organization created by the United Nations to regulate deep-sea mining and ensure that seabed resources are used for the benefit of all humanity. Over the years, the authority has issued numerous exploration licenses to countries and private companies, allowing them to study the area and assess its mining potential. However, critics argue that mining regulations are being developed faster than scientific understanding, and that humanity is rushing toward exploitation without fully understanding the consequences. Many scientists and environmental groups are now calling for a global moratorium, a temporary pause on deep-sea mining, until more research can be done. Supporters of deep-sea mining argue that the world urgently needs these metals to transition away from fossil fuels and fight climate change, pointing out that land-based mining causes deforestation, pollution, and human rights abuses. Opponents counter that destroying one of Earth's last untouched ecosystems is not a solution, but a repeat of past environmental mistakes, only this time in the deepest and least understood part of the planet. Several major technology and automobile companies have already stated that they will not use metals sourced from deep-sea mining, highlighting the growing ethical and environmental concerns surrounding the issue. The debate has become a defining question of our time, balancing technological progress against planetary responsibility. Although most people will never see the Clarion Clipperton Zone, its future is closely connected to our daily lives. Every device we use and every energy decision we make pulls resources from somewhere on Earth. The CZZ represents a critical test for humanity, asking whether we can learn from past mistakes or whether we will continue to exploit new frontiers without fully understanding the cost. After remaining untouched for millions of years, the deep ocean now faces human decision-making, and the choices made today will shape marine ecosystems for thousands of years into the future. The question is no longer whether we can mine the deep sea, but whether we should.